Hey everyone, Neil deGrasse Tyson here. We're about to take a deep dive into the cosmos, guided by the most powerful telescope ever built, the James Webb Space Telescope. This magnificent feat of engineering isn't just bigger and badder than Hubble. It sees the universe in a whole new light, or more accurately, infrared radiation. And what it's seeing is blowing our minds. We're talking about peering back billions of years closer to the Big Bang than we ever thought possible. We're talking about glimpsing the very first stars and galaxies that ignited from the primordial soup. This isn't science fiction, folks, this is the real deal, and the discoveries are pouring in faster than meteor showers in a cosmic storm. So buckle up, get ready for some mind-blowing visuals, and prepare to have your perception of the universe forever changed. One of the most profound questions humans have ever asked is, how did it all begin? This question has puzzled scientists, philosophers, and curious minds for centuries. The quest to understand our origins has driven countless explorations and theories. Well, the James Webb Telescope is giving us a front-row seat to the universe's earliest chapters. This marvel of modern engineering is peering deeper into space than ever before, capturing images that are both breathtaking and enlightening. We're talking about galaxies so old, so distant, that the light we're seeing from them has been traveling for over 13 billion years to reach us. Imagine, the light we see today started its journey long before our planet even existed. That means we're seeing these galaxies as they were just a few hundred million years after the Big Bang. This is like looking back in time to witness the universe in its infancy, a period shrouded in mystery until now. These aren't your typical well-formed spiral galaxies like our own Milky Way. Instead, they are raw, untamed, and still in the process of formation. No, these are clumpy, irregular, still in their chaotic infancy. They are the cosmic toddlers of the universe, full of potential but not yet fully formed. They're filled with the raw materials of the early universe, mostly hydrogen and helium, the building blocks of everything we see around us. These elements are the fundamental ingredients from which stars, planets, and eventually life itself would emerge. And here's the kicker. These galaxies are smaller and more numerous than our current theories predicted. This unexpected discovery is reshaping our understanding of the early universe. This tells us that the early universe was a much more active and dynamic place than we previously thought. It was a bustling, energetic environment, teeming with activity and change. It's like finding out that your grandparents weren't just quietly sipping tea in their youth. They were out there starting a rock band. The early universe was a place of intense creativity and transformation. These discoveries are forcing us to rethink our models of galaxy formation. Our previous theories are being challenged, and new, more complex models are emerging. They're showing us that the universe didn't just slowly evolve from a smooth, homogeneous state. Instead, it was a turbulent, ever-changing landscape, full of surprises and rapid developments. It was more like a cosmic mosh pit, with galaxies colliding and merging, sparking intense bursts of star formation. These collisions and mergers played a crucial role in shaping the universe as we know it. And this is just the beginning. The James Webb Telescope is only scratching the surface of what's out there. The deeper Webb looks, the more of these ancient galaxies it's finding. Each new discovery adds another piece to the puzzle of our cosmic origins. It's like we've stumbled upon a treasure trove of cosmic fossils, each one holding clues to the universe's epic origin story. These ancient galaxies are the key to unlocking the secrets of how everything began. Finding life beyond Earth, even if it's just a single-celled organism, would be arguably the biggest scientific discovery of all time. Imagine the implications for science, philosophy, and our understanding of our place in the cosmos. It would change everything. And the James Webb Telescope is giving us our best chance yet of finding it. This marvel of engineering is equipped with the most advanced technology ever sent into space, designed specifically to peer deeper into the universe than ever before. How? By analyzing the atmospheres of planets orbiting other stars, what we call exoplanets. These distant worlds, orbiting stars light years away, hold the potential to reveal secrets about the building blocks of life. Now, we can't exactly travel to these distant worlds, yet, but Webb can do the next best thing. It can study the light passing through their atmospheres. This light carries with it the chemical fingerprints of the gases present, allowing us to understand their composition. And guess what? Webb is finding water. Lots of it. Water vapor in the atmospheres of these distant planets is a promising sign, as water is essential for life as we know it. We're talking about giant gas giants with atmospheres teeming with water vapor, far more than we ever expected. These findings are reshaping our understanding of where water can exist in the universe. Now, before you get too excited about alien whales swimming in these watery skies, these planets are probably too hot and gaseous to support life as we know it. Their extreme conditions make them inhospitable for life forms similar to those on Earth. But, and this is a big but, their existence tells us that water, a key ingredient for life, is surprisingly common in the universe. This raises the possibility that other more Earth-like planets with water might exist out there. And that's just the tip of the iceberg. Webb is also uncovering new exoplanets at an unprecedented rate, each one a potential candidate for further study. Webb is also finding other intriguing molecules in exoplanet atmospheres, things like carbon dioxide, methane, even hints of organic compounds. These molecules are crucial because they can be indicators of biological processes. These are all potential biosignatures, chemical hints that life might be present. Detecting these molecules is like finding a trail of breadcrumbs leading us to the possibility of life. We're still in the early days of exoplanet exploration, but Webb is already revolutionizing the field. Its discoveries are paving the way for a new era of astronomy, where we can study these distant worlds in unprecedented detail. It's giving us our first real glimpses into the atmospheres of alien worlds, and the possibilities are tantalizing. Each new discovery brings us one step closer to understanding the potential for life beyond Earth. Who knows, maybe, just maybe, Webb will help us answer that age-old question, are we alone? The search continues, and with each passing day we get closer to uncovering the mysteries of the cosmos. Black holes. Just the name conjures up images of cosmic monsters lurking in the darkness, devouring everything in their path. And while that's not entirely inaccurate, it's also not the whole story. Black holes are some of the most extreme and fascinating objects in the universe. They're regions of space-time where gravity is so strong that nothing, not even light, can escape. They're born from the death throes of massive stars, and they play a crucial role in the evolution of galaxies. Now, you might think that observing something that doesn't emit light would be impossible, but that's where the James Webb Telescope's infrared vision comes in handy. See, black holes might be dark, but the material swirling around them, caught in their gravitational grip, gets heated to millions of degrees. This superheated material emits intense radiation, including infrared light, which Webb can detect. And what it's seeing is giving us unprecedented views of these enigmatic objects. Webb is peering into the hearts of distant galaxies, revealing the supermassive black holes lurking at their centers. It's witnessing the jets of energy and matter spewing from these black holes, stretching for thousands of light years. These observations are helping us understand how black holes grow and evolve, how they influence the galaxies around them, and how they shape the large-scale structure of the universe. Stars, those twinkling points of light in the night sky, aren't just pretty to look at. They're the cosmic engines that drive the evolution of the universe. They produce the heavy elements that make up planets, and ultimately, life itself. But where do stars come from? Well, they're born in vast clouds of gas and dust called nebulae, stellar nurseries where gravity pulls material together, igniting nuclear fusion and giving birth to new stars. The James Webb Telescope, with its infrared eyes, is the ultimate tool for studying star formation. Why? Because infrared light can penetrate the thick clouds of gas and dust that obscure visible light telescopes. Webb is giving us stunning views of these stellar nurseries, revealing the intricate details of star birth. It's seeing the jets of gas erupting from newborn stars, carving out cavities in the surrounding material. It's witnessing the shock waves from these jets triggering the formation of even more stars. These observations are helping us understand the complex processes that govern star formation. They're showing us how stars influence their environment, how they contribute to the chemical enrichment of galaxies, and how they shape the cosmic landscape. Of all the questions humans have ever pondered, perhaps none is more profound than this. Are we alone in the universe? This question has fascinated scientists, philosophers, and dreamers for centuries, driving us to look up at the night sky and wonder about the possibilities. The James Webb Space Telescope, with its ability to study the atmospheres of exoplanets, is bringing us closer than ever to answering that question. This marvel of modern engineering is designed to peer deeper into space than any telescope before it, capturing the faintest glimmers of distant worlds. Webb is focusing on planets in the habitable zones of their stars, regions where temperatures are just right for liquid water to exist on the surface. These so-called Goldilocks zones are neither too hot nor too cold, making them prime candidates in our search for life. And it's not just looking for any water, it's looking for water in the right places, like on the surfaces of rocky planets, where life as we know it is most likely to arise. The presence of liquid water is a key indicator of potential habitability. Now, finding another Earth, a planet with continents, oceans, and maybe even life is still a long shot. The vast distances and the sheer number of stars make this a daunting task, but the potential rewards are immense. But Webb is giving us our first real chance of finding such a world. Its advanced instruments and unprecedented sensitivity are opening up new frontiers in our quest to understand the cosmos. It's equipped with instruments that can detect the faint signatures of water vapor, oxygen, and other potential biosignatures in exoplanet atmospheres. These chemical fingerprints could be the telltale signs of life. These observations are helping us narrow down the search for life beyond Earth. By analyzing the data, astrobiologists are piecing together the puzzle of where life might exist. They're telling us which planets are most likely to be habitable, and they're giving us clues about the conditions that might be present on their surfaces. This information is crucial in guiding future missions and studies. We're still in the early days of this search, but the possibilities are tantalizing. Each new discovery brings us one step closer to answering the age-old question of whether we are alone. With Webb's help, we might finally be on the verge of discovering that we are not alone. The journey is just beginning, and the future holds endless possibilities for what we might find. From the ancient galaxies that formed shortly after the Big Bang to the potential for life on distant exoplanets, the James Webb Space Telescope is rewriting our understanding of the cosmos. It's a testament to human ingenuity and our insatiable curiosity to explore the universe around us. And this is just the beginning. Webb has only been operational for a short time, and it's already making groundbreaking discoveries. Imagine what wonders it will uncover in the years to come. If you're as fascinated by space exploration as I am, be sure to like this video, subscribe to the channel, and leave a comment below letting me know what you're most excited to see from the James Webb Telescope. Keep looking up.